In this video, I have a function and the value of a for you. I want you to find a couple things. Number one, I want you to find the Maclaurin series. Number two, I want you to find the expansion. And then number three, I want you to determine the radius of convergence of the Maclaurin series that you found. So number one, let's to find the Maclaurin series, we have to do some setup, which is the derivative. We plug in the value of a and then we determine the terms. So first of all, how many terms we are going to use? Let's use 5. So I will be using n equals to 0, 1, 2, 3, and 4. So that is enough for 5 terms. So when n is equals to 0, we are not taking any derivatives, so which is just a cosine of x. When n is equals to 1, we take the first derivative. The derivative of cosine is negative sine. And then n equals to 2, second derivative. The derivative of sine is equals to cosine, so the negative stays there. And then the triple prime x, the derivative of cosine is negative sine, so we have two negatives, so that becomes a positive. And then n equals to 4, the fourth derivative, the derivative of sine is equals to cosine, and then we have to plug in a equals to 0. Why a equals to 0? Because in a Maclaurin series, a must be equals to 0. So let's do that in a different color to give you a better comparison. F of 0, so that is cosine of 0, which is equal to what? What is cosine of 0? Do you still remember your unit circle in trigonometry? So cosine of 0 is equals to 1, and then f prime of 0, so that is negative sine of 0, that is equals to 0, and then f double prime of 0, so that is negative cosine of 0, that is negative 1, and then triple prime sine of 0 is equals to 0, and then the fourth prime of 0, so that is cosine of 0, which is equals to 1, and then you build the terms based on the Maclaurin series, which is what I have on the right hand side for you. So for the Maclaurin series, first we have a numerator, right? So the numerator is straight from the plugin. So the nth derivative, which is the 0 derivative at x a equals to 0, we have a 1, and then n factorial, which is a 0 factorial, right? Again, you have n equals to 0, n equals to 1, n equals to 2, n equals to 3, and n equals to 4. And then on the next one, you have x minus 0 raised to the 0 power. So the next one is 0 divided by 1 factorial, x minus 0 to the first, and then negative 1 divided by 2 factorial, x minus 0 to the second, and then a negative 0 divided by 3 factorial, x minus 0 to the third, and then 1 divided by 4 factorial, x minus 0 to the fourth. Okay, let's take a look at what that equals to. So the first one is 1 times 1, that is equals to 1. Any non-zero raised to the 0 power is equals to 1, so that's why x raised to the 0th is equals to 1. And then number 2 is easy. When the numerator is 0, the whole thing is 0. And then this you have a negative 1/2 x squared, and then you have a 0, and then this one you have a 1 4 times 3 times 2, that is 24, and then x to the fourth. So we have the first 5 terms, and then the function is f of x equals to cosine x. So what is the Taylor series expansion? The Taylor series expansion is you have a 1 plus a 0 minus a 1/2 x squared plus 0, and then plus 1 over 24 x to the fourth, and then so on and so forth. I just gave you the first 4 terms, and then you clean that up, so that is equals to 1 minus a half x squared, and then plus 1 over 24 x to the fourth, and then plus dot 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 dot. So looks like we have an alternating series right here. So what is this called? This is called a Taylor polynomial. What about the Maclaurin series or Taylor series? You already let a equals to 0, so we have to call that a Maclaurin Maclaurin series. So that is summation n goes from 0 to infinity. So this one you have to observe the pattern. So first of all, I see a plus minus alternates. So that means there must be a alternating term. So let's try -1 raised to the n. Is that going to work? When n is equals to 0, we have a positive 1. When n is equals to 1, we have a negative. So the -1 raised to the n works. Okay, what else? So looks like we have the x. So how about x raised to the 2n? When x is equals to 0, we don't have any x. When x is equals to 1, we have a 2. When x is equals to 2, we have a 4. Because look at the exponent. That is always an even, right? In order to get an always even, you have to multiply the n by 2. And then what about the denominator? The denominator, you have a 2, you have a 24. So this one takes a lot of practice in order to figure out the denominator. So that is the hardest part, or probably the hardest part of a Maclaurin series. So this one is 2 times n factorial. This takes a lot of practice. How do you do this fast and accurate on the test? You have to do your homework. All right. And then, so this is called the Maclaurin series. So the biggest piece is finished. And then the next thing we will have to do is we have to determine the radius of convergence. So to determine the radius of convergence, I will just use the ratio test. And then I am going to let an be the entire series. So -1 raised to the n, x raised to the 2n divided by 2n factorial. And then the an plus 1. So that is equals to -1 raised to the n plus 1. And then this is a x 2 times n plus 1. That is 2n plus 2 divided by 2n plus 2 factorial. And then looks like we have to simplify the an plus 1 a little bit. An plus 1, so this is a -1. I will just use one big fraction. -1 to the n, and then -1 to the first, x raised to the 2n, and then x squared. The denominator, you have a 2n plus 2, and then a 2n plus is a decrement by 1, so the next one is 1, and then a 2n factorial. The purpose of doing this is I want to get rid of these 2n factorial, and that takes some practice. That's why you have to do your homework in this kind of lesson. So, and then we have limit as n approaches to infinity. We have to set up the ratio, the next term divided by the previous term. So this is a limit as n approaches to infinity divided by, so we have -1 to the n, and then a -1 to the first, x to the 2n, and then x squared divided by 2n plus 2, and then 2n plus 1, and then 2n factorial. Okay. Oh, actually, that is not done. We have to divide by an, right? So divided by an means we multiply the reciprocal of an, because an is a fraction. So the reciprocal of an, we have 2n factorial on top, and then everything else goes to the bottom. And then x raised to the 2n, and then we do some cancellation. X raised to the 2n, x raised to the 2n. All right. And then the factorial will be gone. And then you rewrite that for me. So since n is always 0 or above, so that is guaranteed positive. So we have limit as n approaches to infinity. We have okay, let's see. Oh, also -1 to the n, -1 to the n. And then the absolute value of -1, we don't care about that anymore. So we have absolute value 1 divided by 2n plus 2, and then times 2n plus 1. Where is my x? My x is a x squared, right? So I have a x squared right here. So this one, one thing that you, this one I don't think you need to worry about the highest degree in the denominator, because once x approaches to infinity, you only have a 1 divided by infinity times the absolute value of x squared. So since x squared is always positive, then you don't even need the absolute value. But the thing is, 1 divided by infinity is equals to 0. So 0 times x squared is already 0. So this is less than 1. So less than 1 means we don't need to solve for x. What does that mean? That is less than 1. So that means the series is convergent for any x values. Is convergent for any x value. So for the radius of convergence, we have this. So this is x, then we have all convergence. So converge everywhere. It's always convergent. It doesn't matter what x is, the series is always convergent. So the radius of convergence, there are two ways to write it. You can say x is an element of all real numbers, so that is one of the ways to do it, or you can use an interval. X goes from negative infinity to positive infinity, which is the same thing of saying all real numbers. So you can let x be any value you want, and the series is always convergent. Alright, so that is the end of this video. I don't want to put two problems in one video because that will make the video too long. If you think my instruction is helpful, let me know in the comment section below. Like the video, share the video for me, subscribe to my channel if this is your first time visiting my channel. Appreciate your help as always. I will see you all in the next problem. Signing off for now.